All right, this problem's a long one. I broke it into parts. This kind of combines the constant motion that we did with the trig. In this situation, you're on a boat going down a river, or across a river in this case. Um, the boat's going 10 meters per second, and the river's flowing east at 5 meters per second. Uh, if we were going with the river, then we would just do 10 plus 5 is 15 like we did. If we were going against the river, we would do 10 minus 5, which is 5. Those are all our relative motions. Um, the um, the issue with this one is that we're going across it. So the 10 meters per second due north, we're going to, well, it's drawn in the picture, but I'm going to draw it again. And the 5 meters per second due east are going to create a right triangle. So I got 5 this way and 10 this way. It wants to know the resultant velocity. Well, it's just a right triangle again, so it's a squared plus b squared. Good lord, that's a b. Equals c squared. So it's just 5 squared plus 10 squared equals c squared. C is going to be our hypotenuse, what we're looking for. So c is going to be 11 meters per second. That's how fast the boat would have to, or that's how fast the boat is going to go. The speedometer on the boat would read 10. That engine is going 10 meters per second. The river speedometer would say 5 meters per second. You put those two relative motions together, because we're going perpendicular to them, they would actually, the boat speed compared to someone on the shore would be 11 meters per second. Now, what direction are we going to go? Because we're not going to go straight across. We're getting pushed to the east as we go straight across. So we're going to end up going northeast, but that's not clear enough. You have to give the angle. So for that one, we're going to find theta. Again, we're going to do theta off the horizontal. So this one, we have the adjacent, we have the opposite. We're going to do a quick little tan trig thing. Tan, what are we looking for? Theta. So tan theta equals opposite 10 over 5. In the calc, you would just do the inverse tan. So you do inverse tan 10 divided by 5. So you get 63 degrees. And you can add the northeast if you want, but 63 degrees and 63 degrees northeast are the exact same thing. So for part B, now it wants to know how long it's going to take us to reach the other side. The distance of the river, I'm going to do the work up here where there's a little more space. D is 100 meters. So the river's 100 meters wide. I want to know how long it's going to take me to cross. I need to know how fast I'm going. This is where you got to think. The river's going 5. The boat's going 10. Together they're going 11. But that 11 is this. Here, I'll draw it in blue. Is this direction. That's not 100 meters. The 100 meters, do that one in black, is straight across. So when we're doing vectors, dimensions have to go, so x dimensions have to go with x directions. Y dimensions have to go with y directions. So if they gave us the distance across in a straight line, then we need to use the speed of the boat in that straight line. So our velocity of the boat is 10 meters per second, not the 11 meters per second. If you use the 11 meters per second, that's the blue vector. You actually traveled further than 100 meters because you're at an angle, which you could calculate that distance because we know the angle is 63 degrees. But that's extra work. Just use the speed of, if I'm going straight across, then what's the only thing pushing me straight across? What's the boat? So I can do a quick V equals D over T. So I'm going to do 10 equals 100 over T. And T is going to be 10 seconds. So regardless of the river, it's going to take my boat 10 seconds to cross. It doesn't matter. The river could be going 100 miles an hour. It's still going to take me 10 seconds to cross that river because the only thing pushing me across the river is the boat. Now, how far downstream, that is dictated. That's the next question. That is dictated by the river. So for C, how far downstream, again, we're looking for D. Let's see, how far downstream to reach the other side. We know it took us 10 10 seconds. And then the question is, well, how fast are we going across this river? Or not across this river. Since it's asking how far downstream, then we need to ask ourselves, well, how fast are we going downstream? And that is 5 meters per second, which is the river. If the river is going 10 meters, we'd use 10. You're going to get a faster speed. Let me slide this stuff up here. Whoop. So so again, we got dt and v. We're going to use v equals d over t again. But this time we're going to use the speed of the river. So 5 equals 10 over, d equals the distance, what we're looking for. T is 10. So 5 times 10 is 50 meters. We'd end up 50 meters downstream. So again, as the river goes faster, we end up further downstream. So if the river was going twice as fast, 10 meters per second, we'd end up twice as far, 100 meters downstream. So the down part is dictated by the river. Now the last question there, let's take a second here. Alright, so for the last one, now it wants to know, well, what direction should you aim the boat so that you do go straight across? Well, if the river's going east, we'll just do a bunch of these, then I want to head my boat against that. So I want to head my boat this way. Now the boat's going 10 meters per second. The vector that represents the water is going 5 meters per second. So then all I got to do is figure out, well, what angle is this so that I get a direction that's straight across. So again, you look at what you have. You're looking for theta. I have the hypotenuse and I have the adjacent side. The only thing that has all that is cosine. Let's move this out of the way. We'll leave that there. So I would do cosine theta equals adjacent 5 over 10. And then if I do inverse cosine, so inverse cosine 5 divided by 10, I get 60 degrees. Now that's 60 degrees off the horizontal. For the answer, it said, didn't read this, but it said what direction off the vertical. So because it specifically said off the vertical, I should have drawn theta up here. It's an easy fix. I just do 90 minus 60, and there's my answer off the vertical of 30 degrees.